All right, so this is Alfonso Berumen again with Pepperdine University in Decision Sciences, and I did a series of parts for a tutorial on factor analysis using UTAUT data in R. And I know that not every researcher will use R, or maybe be apt to using code in R or open source code in R, and so you have an option here for this data programmers. This is a supplemental, so if you didn't watch parts 1 through 3, you may not have any idea what's going on. So I would still advise that you do actually watch those first 3 parts within R. This kind of matches or mirrors this in a consolidated fashion, right? Or mirrors that those results and those steps in a consolidated fashion. So I actually have a do file, and similar to R, there's a working directory you can specify as that's the folder that you're working out of. So this is my folder. Obviously, you would adjust that for your own folder path, and then I'm using actually the SPS version of the same data set. Not a big deal. I'll provide both files. But we're going to go ahead and sort of run this top area. So the way I would do this is actually copy here, and then paste here, and then I would run that. Don't worry too much about these error messages. This is actually just comments that were executed, right? So I have a comment here. And then you also have the actual executed code that is actually meaningful, right? And you can see that this data showed up. These are the variable names. I could even look at and take a peek at the data, so you can browse through that as well. And what we'll see too is that I'm actually going to start with the top area is looking at is it acceptable to run factor analysis. We're going to look at the KMO and the Bartlett. So we'll run that factor test step, and then we'll also look at the determinant as well. So let's go ahead and take a look at that. So I'll go ahead and copy there and then paste that and run that. And you do see, so let's kind of go up here. Yeah, determinant, it is really small, but one of the things that we looked at with this is that the value has to actually be larger than a very small number, right? So the rule of thumb is greater than point, and then 4 zeros 1, right? 0.0001, we're okay. I can't really see this, right? It actually cuts off at 3 decimals, so I need to. You actually see here, we create a correlation matrix, and then we looked at the determinant, and you do see there that it is greater than that value, right? There's 1, 2, 3, 4 zeros, right? And then let me actually see if I can make this a little bit. No, it's fine. So that is sufficient for us, and then you could see as I go back up to the top, you see the correlations. We took a look at that in the previous tutorials, and then you can kind of see here, if I look, I have my Bartlett's test, and you have that very low p-value, so I can reject the null, that the variables are not intercorrelated, so factor analysis is sufficient. And then the KMO I'm also looking at as well. For the KMO, pretty strong there. So KMO, I generally want to be, so in this case we have 0.861, and for my KMO, I'm looking for a value of, over 0.9 would be excellent. Between 0.8 and 0.89 would be pretty good, and we're actually within that for the KMO. So looked at the correlation matrix, also looked at the determinant. Sorry, this isn't a little bit larger, but you can kind of see how we're working within STATA to produce a very similar process that was covered in the R sequence. So now we're kind of transitioning to, okay, exploratory factor analysis. How many factors is appropriate? So we're going to go look at our eigenvalues, and we'll go ahead and print that. And you'll see that there's a line at 1. And so the 6 actually we discussed is slightly below 1, right? 6 factors. And we did say that there is a strong theoretical argument that this is okay. In fact, also from a mathematical side, with respect to variance explained, it's okay as well. So we're going to go ahead and go forward with our 6, but again, after that sort of bend in the elbow, there's really not as much information gained or as much variance explained after that point. So justified in using 6, we kind of discussed the logic in the previous tutorials. So we're going to go ahead and proceed with our factor analysis. So I'm going to go ahead and copy and paste that and then execute that in my command area, and then you can kind of see I have the rotated factor loading, so the pattern matrix, and I also have some info up here around the data, but you can kind of see as well with the pattern matrix, you can kind of see if, okay, so the first one, I'm looking for high loadings. So the first one, high loadings for the E variables or E items. So that largely measures the effort expectancy. I'm seeing or glancing over here, factor 2 looks like subjective norm, right? So you can see those high loadings, high loading. And then you can go on and kind of make similar inferences about what each of those factors represent. All right, so kind of moving on, you can see I could save the scores, right, and use that for additional analyses for those 6 factors. But we'll go ahead and move on to the reliability. We're just going to look at the Cronbach's alpha, so you see that alpha function there, and then we'll see. I'll just copy and paste. You see that alpha function, and we'll go ahead and run that. And if we scroll up to our factor alphas, you can see, yeah, so similar observations. We can see the PE, we're good to go with our Cronbach's alpha in terms of that 0.7 cutoff. And then you can see here, this column here is if that item was removed, right? So you also see something similar within SPSS. If you use SPSS, we looked at our output earlier, but you can kind of see that the impact in the alpha if that item was removed. And then let's go to our kind of troublesome construct. You can kind of see there, right, if that item was removed, what would happen to the alpha? And FC1 has always given us problems, right? That's a consistent pattern for us. So quick and dirty. There's some other reliability measures we looked at within R, right? So we looked at omega as well, and composite reliability as well. So I would review that tutorial to get some additional information, other reliability measures that are used to assess your survey data. So we're going to go ahead and move on to the CFA model. So let's go ahead and run that. And for context, I am using the standardized values. However, as I mentioned in the previous tutorial, there's many different variations and modifications that can be done to this. So I do want to caveat that. And part of this is just looking at the documentation, and I would say both within R and STATA, but in any other software you use for that matter, to be sure that you're using the appropriate variation. So we're going to use our CFA, and this is, you know, as basically as close you could get to replicating the R results using maximum likelihood. And you can see if I scroll down, I have those coefficients, and what we'll actually look at is also, more specifically, what we're often looking at is the fit, right? So I actually have some code to look at the goodness of fit, and if we take a look at running that guy, and again, I'm not taking a deep dive as we did that within R. This is more of a supplemental to provide a resource for those kind of transitioning to STATA or leveraging STATA within their research study. All right, so you have the chi-square up there. So again, I mentioned in the previous tutorial that it is sensitive to number of data points or sample size. So that's a challenge for us, is we're going to reject the null when in fact we don't want to with respect to the chi-square. Not a big deal for us, and we'll actually then go and take a look at the RMSE A. So similar takeaways with the RMSE A as we looked at within the context of R as well. So RMSE A, you can kind of see the value there, 0.083, so less than or equal to 0.08. Acceptable for us. We're kind of on the cusp there, as mentioned, and then you can see the CFI. Ideally, with the CFI and TLI, would be at 0.9 or higher. And as a sort of a reminder, TLI is kind of a penalized version of the CFI. Finally, the size of residuals, or the SRMR, that's going to kind of measure the standard residuals between the observed and model implied covariances. Lower value is better for us, and we're actually ideally at less than or equal to 0.08. And here you can see that we're at 0.105, right? So questionable there as well. So as I mentioned, modification indices may improve this, so we can actually produce that as well. So this would provide us suggested changes for our model. So let's go ahead and produce those within STATA, and you can see that output there, right? So you can kind of see the facilitating conditions that item 1 is in that output as well. So when you look at the MI column, you're looking for larger values, and it actually does sort of suggest to us that that there are some challenges here within our. You can kind of see that there, right? I actually in the previous exercise I actually attached FC1 to EE, right? I removed it from its kind of specified construct of FC, or facilitated conditions, and then moved it into EE. So you see that large value there. So again, this is giving us more kind of information on what might improve our model and what might we make adjustment wise to improve the fit. So that kind of wraps up the sequence of tutorials. Again, this was a consolidated version. I didn't look at all this, sort of all the STATA steps in depth. It really should be viewed within the context of the R tutorials, but I want to provide a kind of supplement for those that will be primarily working within STATA with their survey data, so you can go ahead and execute CFA. And that sums it up. So good luck with your research, and good luck conducting your factor analysis.